Businesses everywhere have complex processes that gather, refine, and analyze data, searching for answers and insights. As the volume, variety, and velocity of data increases, legacy processes can't always keep up. IBM's Watson Data Platform is here to help. Today we'll be looking at a multi-step business process that moves data through several different steps, refining and ultimately getting to the final output. The problem with this process is that one of the steps was taking a very long time, up to several days for a particular task. This was a big bottleneck and needed to be dealt with. The problem was, in very densely populated areas, a particular claim was being calculated against a prospect to find the distance between the two. In very densely populated areas, that could be millions of calculations, and the calculation was taking too much time using the legacy process. Watson Data Platform was brought into the picture in order to bypass this seventh step. The data was moved from the on-premise system in step 6 through Watson Data Platform and then back to the on-premise system in step 8, ultimately reducing the time from days down to minutes. Here's how Watson Data Platform was able to solve this problem. The data files were taken from the on-premise system using IBM's Lift to get the data into DB. Once it was in DB, the calculations for distance were calculated using the spatial extender features of DB2. Once the final result was available, Data Connect moved the data from DB into object storage, where it was then available to be pulled back on-premise and continue in the workflow. The SDK for Node.js and the Node-RED starter boilerplate were used in order to coordinate the workflows between the on-premise and the cloud solution. Now we'll move to the actual demonstration so you can see this solution in action. In order to visualize the solution, I've modeled it within Node-RED so you can see the different steps that we had up through step 6, and then when we get to step 7, that's where we're going to use the Watson Data Platform in order to perform those tasks. This particular instance of Node-RED is running on my local machine, so this would be the on-premise system, and it could be programmed using any programming language. Because the Watson Data Platform components that we're utilizing are exposed through various APIs, any programming language could be used. Next, we have a Node-RED flow that's actually running on Bluemix, and this is where we'll do the actual calculations within our DB instance, and then use Data Connect to move that data into object storage. This particular workflow is started by making a GET request to the following endpoint, and then that kicks off the workflow. So that's the way that we'll integrate between the on-premise workflow and the cloud workflow for a true hybrid solution. Finally, once the Data Connect task has moved the data into object storage, a message is sent back to the on-premise workflow so it can continue on. You can see right here, this is where we're making the call to the WDP start endpoint that we saw before. And then once we get the response back, we continue on with the workflow. I'm going to kick this workflow off because it takes a couple minutes to run, and then we'll start looking through the different components while it's running. But before I do that, one other thing I did want to show is the object storage repository. Currently there's no objects in here, and then also the files that we'll be working with. I have a particular directory, Node-RED here, that has 2 different files, which is what the raw input from the diagram that we showed before. And then there are a few scripts that will be utilized within the Node-RED workflow in order to accomplish the various tasks. The files look like the following. So we have a claim file that has just, so it has 2,806 records, and it's basically just an index with a unique identifier, a product type, and then a geocoded latitude, longitude in a certain format. And then we also have a prospect file, which is the similar format. It doesn't have a product code, but it has 332,373 records, a unique identifier for each prospect, again the geocoded string, and an ID. So as we kick off the tasks, you'll see these files being moved over. And then finally, just to clear everything out, I've set up a couple of scripts that we're going to truncate all of the tables that will be utilized in this task. So I'm just going to kick that off real quick. Make sure that all of our files are not loaded, and then we'll do row counts on each of those tables just to make sure that everything is zeroed out before we get started. And then once we finish, we'll run these again so we can see them being populated. So I can see my results over here. If I expand each of these, I can see the row counts for each of the different tables is set to 0. So these tables have been successfully truncated. So now I'm going to move back to my on-premise workflow and start this. And so as that starts moving through the various steps, we're going to get to step number, what would be step 7, and that's where we start to leverage the Watson Data Platform to optimize that particular step that became a bottleneck. So the first thing that's happening is Lift CLI, which is a command line interface for IBM's Lift product, is loading those files into -db. That's just running a script, which is this lift load script. So we'll open that real quick and take a look at it. This is just calling the command line interface. There's a property file that has the credentials to my -db instance, and then I'm just moving those files up. First we put the file onto the server, and then we load that, and I do that for both the claim data and the prospect data. We can see that in the next task it's moved on to the Watson Data Platform workflow, which is over here on my second tab. So that has just been requested, and the scripts will be running in DB2. And then once that finishes, we'll continue on and run this object storage script. So the process is now checking to see if the file has been written to object storage. Once that file has been written to object storage, it will pick it up and continue. I'm going to switch over to the debug tab so that we can see the output as it finalizes. So it does take a couple seconds in order to process that file and make it available. Keep in mind this process before was taking a weekend to run, so someone had to monitor it. They could only submit certain components of the job at a time because it had to be broken up. And now within a matter of minutes we have loaded the file up into -db, run the calculations, moved the result set into object storage, and then pulled the object storage data down to our local file system and continued on with the process. At this point it's no longer waiting because it's identified that the file is available. It's now downloading it to my local file system, and if I open up my Finder window, we can now see this DC out file, the message that everything completed successfully. So if I open this DC out file, we'll be able to see the output, which is an ID. Actually, let me move over to the correct file here. It's still loading. This is a large file. So we were calculating the nearest 3 prospects to the different claims, and you can see that I have a unique identifier for the claim, I have the unique identifier for the prospect, as well as the distance between the two. So that whole process was done in a matter of minutes, something that was taking days before. And this is truly a hybrid solution. So we started the workflow on premise, we then loaded the data into the cloud, kicked off a workflow that was running in the cloud. The calculations were done in -db, then moved to object storage. A notification was sent back that the file had been moved. Then the object storage process checked for the file, brought it down to our local file system where it could then continue on in the process. And then here's the final output that was generated. If we go back into the workflow here, those scripts that we ran before, so we'll clear the output and then just run row counts on these tables. We'll see that the first table has the 2806 records from the claim file. The prospect file has the 300,000 plus. Those are then broken into a different structure in order to convert the geocoded content into a point file that's recognized by the DB2 spatial extender functions. And then that output is calculated, and then ultimately the original claim IDs are put back onto the file, and then it's made available for the process. So you can see here within the script, we're loading the different tables within -db. We're creating a spatial index. We're then going in and doing the distance calculation, and we're only pulling over the top three, so we rank those and then pull the three closest ones. Load that back into our output, and then we pull in the different IDs, which were on the original files that we brought in, the prospect file and the claim file. And that's how our solution worked. So hopefully you've been able to see how the Watson Data Platform can be utilized to optimize a workflow that has got a bottleneck because of processing or whatever constraint. Thank you and have a great day.